So the GED loves to hide geometry problems and word problems. I know everyone's always complaining about the Ferris wheel problem. I see that all the time. Um, um, or there's a lot of examples, fences and mirrors, and a lot of times it'll be about building. But let's take a look at this problem here. We can see the geometry hidden in it. It said the blades of a helicopter are 9 feet long. If the blades spin at a rate of 300 revolutions per minute, the tips of the blade will travel how many feet in 30 seconds? And then we're asked to round our answer to the nearest 10. Now, the first thing to realize is the shape that the blades of a helicopter make. Think about it. Let's look at it. Let's imagine we're looking at it from a top view. If you have the helicopter blades and they go spinning around, well, it's pretty clear to see that that forms a circle. So right now I'm in the world of circles. And I know that each one of these blades are 9 feet long. So if I draw out my little blade here, I'm going to emphasize this blade and say that's 9 feet long. Do you see how the blade goes from the edge of a circle to the center of the circle? That blade must represent the radius of this circle. Okay, radiuses go from the center of a circle to the edge. So we just found that this helicopter's blades form a circle with a radius of 9 feet. Okay, now let's keep going. It says the blades spin at a rate of 300 revolutions per minute. I'm just going to write that down. They spin at 300 revs per minute, and we usually use a slash to represent the word per because we're so lazy. Okay, now what are we looking for? We're looking for how far the tips of the blade will travel in 30 seconds. How far the tips of the blade will travel in 30 seconds. Well, the tips of the blade are here, and if you think about it, the tips of the blade are moving around the outside of this circle. And so when you move around the outside of a circle, that's known as circumference. So we will start with the circumference formula. Now, when you go to look at your GED formula sheet, okay, you need your GED formula sheet for this problem unless you have your circumference formulas memorized. You're going to see that you have options. You have one that says C equals 2 pi r, or you have one that's C equals pi d. And you might say, well, which one should I use? Now, they'll get you to the same place. So you could choose either one, but I'm a lazy mathematician. I'm going to choose the one that makes my life easier. What thing do we have here? Remember that we know the radius of our circle. So I'm going to choose the formula that has the r in it. R stands for radius. D stands for diameter. Since I wasn't given diameter, I won't use that formula. So I'm going to use this one. Now, circumference is the thing I'm looking for. It remains a mystery, so it remains a letter. I don't change numbers when I plug into a formula, so the 2 stays 2. Since this is a word problem and I've been asked to round, I'm going to use the decimal approximation for pi, 3.14. That's not exactly what pi is equal to, but it's close enough, especially if I'm only going to round my answer at the end anyway. So I'll call pi 3.14. And if you're wondering where I got that number, pi is approximately equal to 3.14 is printed right there on your GED formula sheet, so you don't have to memorize that. And now I'm going to plug in the thing that I know. I know the radius of my circle. The radius is 9 feet. So great. So first step here, I've plugged in for this circumference. Now this circumference is going to tell me how far that we go around in one circle. Circumference is just once around the circle here. So let me multiply this out, and I'm using my TI 30XS calculator. So I'm going to do 2 times 3.14. And for those of you wondering why I'm multiplying, see up here in my formula, these things are all shoved together. When things are just shoved together with no symbol between them in math, it's a pretty safe assumption that they're multiplying. So 2 times 3.14 times 9 gives me 56.52. Now I know I've been told to round to the 10 place, but be careful not to round to the 10 until you're finished with your problem, or you'll lose too much information. Now, I'm not finished yet because this circumference formula only gives me once around the circle. But these helicopter blades are spinning super fast. Look how fast they're spinning. They're spinning at a rate of 300 revolutions per minute. 300 revolutions per minute. So they're going to go around 300 times every minute. Now, I've been asked to see how far they're going to travel in 30 seconds, not a minute. So this stumps people. Oh my gosh, what am I going to do? But I would say that most of us know. Do you know that 30 seconds is half a minute? I bet you do. Let's think about that. If a full minute is 60 seconds, then 30 seconds must be half a minute. So instead of going 300 revolutions, which is how much I go in 1 minute, I'm going to go half of that. Half of 300 revolutions. And you can do that in your calculator by replacing the word of with times, but I happen to be able to half pretty well in my head, so that's 150 revs. In 30 seconds, I can do 150 revolutions, 150 circles, okay? That's what a revolution is, a circle. And so I'm going to take this distance, this circumference, that's once around the circle, and I'm going to multiply it because I can do that 150 times. Hear me use that word 150 times. That means multiply by 150. I need my trusty GED calculator again. So I'm going to take my 56. I'm a little mad at myself actually right now. Can I change something? I don't like the way I wrote this. I don't want it to look like it's a new expression. I'm going to write it as a new line. It's really 150 times around the circle is equal to 56.52 times 150. If you don't see the difference of what I wrote, it's not that big of a deal. I'm just an anal retentive mathematician, and I want to make sure that each equation that I have is equivalent to the one before it, and so I was just caring about the way I wrote that down, that notation, wanting it to be proper. Okay, so when I did 56.52 and I multiplied it by 150 to figure out how much it would be for 150 revolutions, I got this number, 8,478. And remember, we're looking at the number of feet because this was the feet circumference around, and now I took this feet, multiplied it by 150 times. I have 8,478 feet. And I'm almost done. Your final act for any problem should be to follow rounding directions. So here I've been told to round my answer to the nearest 10. Now here's my tens place, but that's the place I want to keep. After my tens place, I'm going to have a cutoff here, and I want to consider the next number, the number that I'm about to throw away, and consider, before I discard this 8, throw it away, is it big enough to matter? If you're past the halfway point, if you're at 5 or higher, your number's big enough to matter. This one sure is. And so its final act before I throw it away is going to be to bump the next number up. And so I see this as 8,480 feet that the tips of the helicopter blade will travel in just 30 seconds. Whew, that's fast.